Hey everybody, Mr. Hunt here. Gonna jump right in with today's topic. We're talking about triangles, a new unit. Really excited about it. One of my favorite units of the year. I want you guys to look over the top of the page with how to classify a triangle. Okay, the sides or segments, the angles, and the vertices A, B, and C. And we just write, triangle. That's the symbol A, B, C. So that's how we can write instead of writing out the word triangle. So I want you to review, look at all the 7 ways to classify a triangle, and then I want you to try these 2 examples. So go ahead and pause it, try it out, and we'll be back in a second. Okay, I hope that you tried it out there. For part A, you should have first seen that there are 2 sides marked as congruent, not a third. At least 2 sides congruent, it is isosceles. And 1 right angle, so it is a right triangle. Right, and by the way, there are always 2 ways to classify a triangle, by its sides and by its angles. On part B, notice that there's 1 mark, here's 2, and here's 3. So they're all different, so it's scalene. And the 110 degrees, that's an obtuse angle, so you're going to have an obtuse triangle. All right, that's just a review of classifying triangles. Okay, as soon as you're good with those 7 terms, those are review terms, you can flip it over, and I want to do a couple examples. We're not going to do the 2 proofs, but we're just going to talk about some other vocab terms. Okay, so we're back here. We're going to talk about 2 theorems, the angle sum theorem and the third angle theorem. The angle sum theorem is one you've been doing probably since you were in 4th grade. I don't know exactly when, but it just says the sum of the angles in a triangle is 180 degrees. That's all we're going to talk about for now with that one. We're going to show why that one's true tomorrow. The other one is the third angle theorem. I love this one. You're actually going to show why this one is true in your homework. Here's what it says. If 2 angles of a triangle are congruent to 2 angles of a second triangle, then the third, and this is the word you can fill in there, then the third angles are congruent. Hence, third angle theorem. So, for example, here's what it says. I have 2 triangles I drew below. It says nothing about their size. All right, they could be the same size, but one could be smaller. Let's say that you know that this one's 110, and this one's 110. So there's 1 angle in each triangle congruent. And let's say you know that these are each, we'll say, I don't know, let's do 40. So that's 40, and this is 40. All right, so if you have 2 angles in a triangle congruent to 2 angles in another triangle, then what we can conclude is that the third angles will be congruent. Basically, think about it. If this is 110 and this is 40, solve for this one, it's going to be 30, right? Just do 180 minus 40. Get rid of that. Minus the 40 and the 110. So you subtract those off and you get 30. Right, and you can do the same thing on the other side. Now, where this comes into play is when you know something like this. I'll just make some other triangles. It's when you know, hey, this angle and this angle are congruent. Oh, nope, I'm doing side, sorry. It's when you know, hey, these angles are both right angles, and then these angles are both congruent. Without even knowing the measure, then you would know that the third angles down here are congruent. So that's where it's important. Obviously, if you have the measures, you could solve for the others, but when you don't have them, it is even more important. Very good theorem. Okay, so now let's talk about a few vocab terms. Hey, by the way, did everybody notice the colors I'm able to do now? This is fun. Doodlecast Pro. Making some nice colors here for me. Although pink is not really my favorite color. But anyways, so let's look at exterior angle. An exterior angle is an angle formed by one side of a triangle and the extension of another side. So for example, angle 1 below. All right, so basically what they've done here, switch to that. So basically what they've done is they've taken this side of the triangle and then extended this side, and all of a sudden you have 2 sides of a triangle, and then the and then they meet at the vertex, and that's angle 1. All right, so angle 1 is an exterior angle. It's on the outside of the triangle. Extend one side. Now, you could also keep going around the figure. Right? I could write 5 over here. There's angle 5. I could extend this. There's angle 6. All right, so you could extend it. In our diagram, the only one is angle 1, though. All right, let's go back. So remote interior angles is the other thing. And why are these two important? Because we have this theorem below, this property about them. What are remote interior angles? They're the interior angles that are not adjacent. Let me change colors, sorry. All right. Well, made a little blot there. There we go. Okay. The interior angles, if I can get this right. So the word you need to write in is adjacent. Adjacent. The interior angles that are not adjacent to your exterior angle. So 1 is the exterior angle. 4 is adjacent. But your remote interior angles are going to be 2 and 3. They're the remote interior angles. All right. How can you remember this too? Think about remote, like a remote island is one that is hidden or secluded or far away from other parts of the island. So it's remote, it's hidden. 2 and 3, they're not close to angle 1, they're hidden, they're far away. Or like a remote control, you use it when you're far away from the TV. 2 and 3 are far away. So now, why is this important? Well, you get this exterior angle theorem. Let me write it below it. Exterior angle theorem. And here's what it says. The measure of the exterior angle is equal to the sum of the 2 remote interior angles. All right, sum means you add them. And we're going to actually show this one in class tomorrow. But here's what it says, is that, and here's what you can write in the example spot. So you can write in that the measure of angle 1 is equal to the measure of angle 2 plus measure of angle 3. Okay, because we know that the exterior angle 1 is equal to the sum of the remote ones, 2 and 3. All right, and really it's pretty simple. I bet you could see from this example. Let's say I knew angle 1 was 120, right? Well, 1 and 4 make a straight line, so if you subtract 180, then angle 4 is going to be equal to 60 degrees, right? And then a triangle is 180, so you say, well, the whole triangle there has to be 180, so what's left between 2 and 3? Subtract off the 60, you're back at 120. So 120 has to be what's left between 2 and 3. Okay. Let's see. I think we're going to do that proof of exterior angles tomorrow. So let's flip it over. The last thing I want to do is look at these 2 corollaries and a couple of algebra examples, and we'll finish up. Get a nice quick video here. Okay, so we're on the third page there. Corollary is this word where we're at, middle of the page. A corollary, we haven't talked about this yet, it's a statement that can easily be proven using a theorem. So right in the word theorem, I've already written it in here. So, guys, what is it? It's another property. So just like theorems show properties of triangles or parallel lines or whatever, segments, angles, whatever we're working with, corollary is the same thing. But we call it something different because it's something that's not as hard to prove, and it's based off of these theorems. All right, it's based off of theorems. So again, very, very similar to a theorem. It's just we kind of call it something different. All right, so here's 2. The first one, the acute angles of a right triangle are complementary. So remember complementary. Complementary means sum to 90. So think about it. If you have a right this one's pretty easy to prove. It's a good one to prove too. If you have a right triangle, you've used 90. Well, how much is left in the triangle? Subtract from 180. There's 90 degrees left between the remaining, I'll call them 1 and 2. There's 90 degrees left between 1 and 2. So then they must be acute. 1 and 2 must be acute. So they're going to be complementary. The other one, let's see, there can be at most one right or obtuse angle in a triangle. Let's see, by the way, don't worry about these numbers, 4, 1, and 4, 2. But 4, 2 says there can be at most one right or obtuse angle in a triangle. Let me keep the same example over here. Well, there's a right angle there. If there was another right angle, you'd already be at 180 degrees, and you still need another angle. You need another positive number, but there is none left. You already spent your 180. Again, another one that we could easily show. Same with an obtuse angle. This is actually best shown using indirect reasoning, which we'll do in a couple of sections. Okay, to finish up, we're going to try 2 examples just to relate this to algebra, make sure we know what's going on. Okay, so we're going to finish up with these 2 examples at the bottom. Let's just find the value of x for each of these. So in part A, we're going to use the triangle angle sum theorem, which says the sum of the angles in a triangle must add to get, or sum to get 180. So we're going to do the 55 plus 54 plus x plus 74 equals 180. And solve from there. So we'll combine these like terms. X plus, this will be 183 equals 180. Subtract 183, we get x equals negative 3. Now some of you are like, oh, I don't like that negative number. Well, just remember, you can have a variable be negative. You just can't have an angle or segment be negative. So if we were to plug this back in, right here, negative 3, well, that angle would then be 71 degrees, and that's fine. And those 3 add, you get 180. So that does work. Let's go over to part B. This one, we have to make sure to identify what type of angles we have in a triangle. So the key thing is this one right here, the 14x plus 1, exterior angle. It's outside. These 2 right here, they are not adjacent. This would have been the adjacent one right here. So these are remote interior. Remote interior. And we've got to use the exterior angle theorem, which says we know that the remote interior angle, the exterior angle, 14x plus 1, is equal to the sum of the other 2, the remote interior, 89 plus 5x minus 7. Okay, we'll do a quick solve. I'm going to combine like terms over here first. 14x plus 1 equals, 82 plus 5x. I'm going to subtract 5x from both sides, and I'm going to subtract 1 from both sides. I didn't show too much of my work. But there's what you get. Divide by 9. X is going to be 9. Okay, now I should make sure when I plug it back in, choose a different color here. Let's see, okay. If I plug back in right here, 5 times 9, 45, yep, that's going to be 38 degrees. And if I plug it in over here, 14 times 9, 140, 126, and so this angle is going to be 127. So yes, I got positive angles, and you can see it works. 89 plus 38 is going to be 127. Okay, so there we have it. Talking about classifying triangles, which should have been a review. Acute, equilateral, scalene. That should have been a review. And then we got basically some new theorems about angles of triangles. You might have known this angle sum theorem, but third angle theorem and exterior angle theorem. And we talked about a few corollaries. All right, we'll finish those 2 proofs tomorrow. That's all I got. Hope everybody has a good night.
Made with Doodlecast Pro.